August 12th, 1987, Dearborn, Michigan. The Ford Rouge Complex stretches across 600 acres of industrial landscape along the Rouge River, one of the largest integrated manufacturing facilities in the world. Viktor Petrov, chief engineer at the Soviet VAZ Automotive plant in Togliatti, steps off a chartered bus with 15 other Soviet engineers, all members of an official delegation studying American automotive manufacturing. They've been granted access as part of Glasnost-era cultural exchanges, and Soviet authorities expect them to gather intelligence on American production methods, while demonstrating that Soviet industry can learn from capitalist techniques without abandoning communist principles. Petrov expects to see impressive automation. Soviet intelligence reports have indicated American factories employ significant robotic capability. But as he walks through the massive doors into the final assembly building and sees what's actually happening on the production floor, he stops walking. Completely stops. His translator has to tap his shoulder twice to get his attention. Stretching before him for what seems like a quarter mile, a river of automotive bodies moves through stations where robots, hundreds of robots, maybe 1,000 or more, weld, paint, measure, and assemble components with mechanical precision. There are human workers present, but they're supervising, monitoring computer displays, making adjustments. The actual production work happens through robotic arms moving with synchronized choreography that looks almost biological in its fluid coordination. A partially assembled Ford Taurus moves past Petrov's position. 6 robotic welders simultaneously attack different points on the vehicle's frame, their electric welding arcs creating a constellation of bright flashes that last exactly 2.3 seconds before all 6 complete their operations in perfect synchronization and the frame continues down the line. Petrov has seen Soviet automation. Soviet factories have some robotic welders, some mechanical systems. What he's looking at isn't incrementally better than Soviet capability. It's different in kind, different in degree, different in a way that suggests the two countries aren't even operating in the same industrial era. His first thought, the one he will later admit saying out loud, "This cannot be a real production facility. It must be a Potemkin factory built specifically for propaganda to impress foreign visitors." But it's not. This is just Tuesday at Ford Rouge, and it's producing 3,000 vehicles today, just like it did yesterday and will do tomorrow. To understand Petrov's shock, you need to understand what Soviet automotive manufacturing looked like in 1987. The VAZ plant in Togliatti, where Petrov has worked for 18 years, is the Soviet Union's showcase automotive facility. Built in 1970 with Italian assistance, the plant was designed to produce Lada vehicles, simple, reliable cars for Soviet consumers. By the mid-1980s, the factory employs 110,000 workers, producing approximately 720,000 vehicles annually. That sounds impressive until you do the mathematics. That's 153 man-hours per vehicle when you account for multiple shifts and support staff. The actual assembly time for a single Lada, from the moment its frame enters the production line to final inspection, requires approximately 200 man-hours. Compare that to the American numbers Petrov has heard whispered, 25 to 30 hours for an American car, produced with perhaps a third of the workforce. Soviet automotive assembly in 1987 remains predominantly manual labor. Workers weld seams by hand with stick welders, a process requiring skill but producing inconsistent results. Body panels are painted by workers wearing respirators in ventilated booths, spraying paint from handheld guns with techniques that haven't fundamentally changed since the 1950s. Paint drips, uneven coating thickness, and overspray waste are constant quality control issues. Engine installation involves teams of 4 to 6 workers manually lowering the engine block and transmission assembly into the chassis, aligning mounting points by eye and feel, and torquing dozens of bolts by hand with pneumatic wrenches. The process takes 45 minutes to an hour, and errors are common enough that supervisors must inspect every engine installation personally. The VAZ plant does have some automation. There are mechanical conveyor systems that move vehicle frames through the factory. There are some hydraulic lifts and positioning systems that assist workers. There's even a robotic welding cell, singular, that handles some frame joining operations for one specific model. Soviet engineers point to this cell proudly when giving tours to local party officials, but the cell represents perhaps 2% of the total welding operations in the plant. The other 98% happens through manual labor, one welder at a time, one seam at a time, one spark at a time. Quality control at VAZ involves inspectors with clipboards, checking sample vehicles pulled from the production line. They use rulers to measure panel gaps, micrometers to check critical dimensions, and their eyes to assess paint quality and interior fit. Defect rates hover around 15 to 20% for vehicles requiring rework before delivery. Soviet consumers accept this as normal. Everyone knows someone whose new Lada required immediate repairs, whose door didn't quite close properly, whose paint had visible drips or uneven coverage. A 3-month waiting list exists for new Ladas despite these quality issues because demand exceeds production capacity and no alternatives exist. Soviet consumers can't choose Toyota or Ford or Volkswagen. They wait for Lada, or they wait longer for more expensive Soviet models that have even longer production times. The ZIL and Gaz plants that produce luxury vehicles for party officials and government use operate with even more manual labor. These vehicles, the limousines and official cars that carry Soviet leadership, require 300 or more man-hours for assembly, with extensive hand-fitting of components and manual finishing of interiors. Soviet officials point to these vehicles as examples of superior craftsmanship, comparing them favorably to American mass production. But the comparison misses the point. America produces millions of vehicles accessible to ordinary citizens, while Soviet elite vehicles are built like custom coaches for the tiny percentage of the population with political privilege to acquire them. Soviet industrial doctrine teaches that automation creates unemployment, that machines replacing workers represents capitalist exploitation rather than progress. Party economists argue that full employment is more important than production efficiency, that keeping workers occupied serves social stability, even if it means lower productivity. Soviet engineers like Petrov understand this as ideological rationalization for technological backwardness, but they can't say so publicly without risking their positions. They've heard rumors about American automation, read carefully censored technical journals, seen grainy photographs of robotic assembly lines. But seeing it, standing on the floor of Ford Rouge watching it happen in real time at scale, creates a cognitive disconnect that ideology can't bridge. American automotive automation didn't appear overnight. The Rouge Complex, built in 1928 by Henry Ford, pioneered integrated manufacturing, where raw materials entered one end and finished vehicles emerged from the other. By 1987, that integrated approach has been augmented with sophisticated automation developed throughout the 1970s and early 1980s. General Motors' Hamtramck assembly plant, which opened in 1985, represents the cutting edge, a 500 million facility employing 260 industrial robots coordinated by computer control systems that manage every aspect of production. The robots themselves come from companies like Unimation and Cincinnati Millicron, specialized manufacturers that have refined industrial robotics through continuous development. A Puma series industrial robot, typical of what Petrov sees at Rouge, operates with 6 axes of motion, can be programmed for complex movement patterns, and maintains positioning accuracy within 0.1 millimeters across thousands of repetitive cycles. Each robot costs approximately $50,000 in 1987 dollars. Expensive but quickly cost-effective when you calculate that one robot can perform welding operations 24 hours per day, with breaks only for routine maintenance, replacing multiple human welders while producing more consistent results. Ford Rouge in 1987 employs more than 1,000 industrial robots across its various production lines. In the body welding shop that so stuns Petrov, approximately 300 robots handle the majority of welding operations. A typical vehicle frame requires more than 200 individual welds. Human welders working in pairs might complete this work in 30 to 40 minutes. The robotic welding cell completes all 200 plus welds in 90 seconds. The robots work in coordinated sequences, multiple arms approaching the frame from different angles simultaneously, each executing precisely programmed weld patterns with consistent penetration depth, perfect bead appearance, and 0 defects. The frame emerges from the welding cell structurally complete, requiring no human touch-up or correction. The paint shop represents another revolution in automation. Traditional automotive painting involves human painters and protective equipment spraying vehicles by hand, an art requiring significant skill and producing variable results. Automated paint systems employ robots with electrostatic paint guns that create precise, even coatings while minimizing overspray and waste. The Rouge paint shop in 1987 applies 6 separate coats: primer, base coats, color coats, and clear coats, entirely through robotic systems. Paint thickness varies by less than 5 microns across the entire vehicle surface. There are no drips, no uneven coverage, no visible spray patterns. Quality that would represent exceptional work for a master human painter is standard output from the automated system, repeated thousands of times daily with perfect consistency. Quality control automation, perhaps, represents the most significant advance beyond Soviet capability. Ford employs laser measurement systems that check hundreds of dimensional specifications on each vehicle as it moves through assembly. Panel gaps, body alignment, glass installation, door fit, measurements that Soviet inspectors check manually with rulers and gauges on sample vehicles get verified automatically on every single vehicle through computer-controlled sensors. If any dimension falls outside specification, the system flags the vehicle automatically and diverts it for correction before it proceeds further. The American approach assumes quality issues will be detected and corrected immediately. The Soviet approach assumes some percentage of defects will reach consumers because comprehensive inspection is too labor-intensive for every vehicle. The final assembly line completes the picture that Petrov finds so shocking. Components arrive from suppliers with precisely timed delivery, dashboard assemblies from one vendor, seat sets from another, wheel and tire combinations from a third. These parts don't sit in warehouses for weeks. They arrive at Rouge hourly, sometimes in the exact sequence needed for the vehicles currently being assembled, a logistics approach called just-in-time inventory that minimizes storage costs and ensures parts are always current to specification. Soviet plants maintain months of parts inventory, partly because supplier reliability is poor, partly because central planning struggles with the coordination required for precise delivery timing. Vyaz has entire buildings filled with stored components representing millions of rubles of capital tied up in inventory that just sits waiting to be used. The assembly line operates continuously through 3 shifts, producing vehicles around the clock except for planned maintenance periods. During peak production, a completed vehicle rolls off the Rouge line every 58 seconds. 58 seconds. From frame welding through final inspection, the entire process requires approximately 20 hours of elapsed time. But because multiple vehicles are being assembled simultaneously at different stages, the output rate reaches phenomenal levels. Rouge produces 3,000 vehicles in a 24-hour period when running at capacity. The entire Soviet automotive industry produces approximately 3,500 vehicles per day across all its plants combined. Petrov's tour lasts 6 hours. His delegation sees not just the assembly lines, but the supporting systems, the computer control rooms, where engineers monitor production in real time, adjusting parameters and optimizing workflows through data analysis. They see the quality assurance testing facilities, where sample vehicles undergo destructive testing to validate design specifications. They visit the training center, where Ford workers learn to program and maintain the robotic systems. What strikes Petrov most isn't any single technology, it's the integration, the way every system connects to optimize the whole process. Soviet factories have islands of automation disconnected from each other, requiring human intervention to move work between systems. American factories have integrated production, where material flows continuously from raw input to finished vehicle with minimal human handling. The GM Hamtramck plant that the delegation visits the following day reinforces everything Petrov has observed. Hamtramck, being newer, shows even more advanced automation. Automated guided vehicles, small robotic carriers, move parts between stations without human drivers. Computer vision systems inspect painted surfaces more thoroughly than human inspectors could. The plant's central computer system tracks every vehicle in production, monitoring quality data, scheduling maintenance, optimizing energy usage, and coordinating supplier deliveries. It's a level of system integration that seems closer to science fiction than industrial reality for engineers whose experience comes from Soviet factories where production scheduling still happens on paper forms filed in metal cabinets. During an evening dinner with Ford engineers, Petrov asks questions that reveal the depth of the capability gap. When told that Ford invested $3.5 billion in automation between 1980 and 1985, Petrov visibly reacts. The entire Soviet automotive industry's capital budget for that same period was approximately $1.8 billion, and that money was spread across dozens of factories producing not just cars, but trucks, buses, and military vehicles. A single American company invested twice what the entire Soviet system allocated to automotive modernization, and Ford is just one of 3 major American manufacturers, all making similar investments. The scale of American industrial commitment to automation and efficiency exceeds Soviet capacity by such a margin that catching up is not just difficult, it might be impossible within the current Soviet economic system. Petrov asks about worker resistance to automation. Soviet doctrine teaches that workers oppose automation because it threatens their jobs. Ford engineers look puzzled by the question. Workers participated in designing the automation systems, they explain. Workers received training for higher skilled maintenance and programming positions as assembly jobs automated. Unemployment didn't rise when Ford automated, production increased, the company grew, and workers moved into better positions. The union negotiated retraining programs and job guarantees. Worker suggestions for efficiency improvements are actively solicited, with cash bonuses paid for ideas that reduce costs or improve quality. The concept seems alien to Petrov's experience, where Soviet workers have no input into production methods beyond following instructions, where 5-year plan quotas are handed down from central planning ministries, where questioning assigned procedures invites political scrutiny. During the return flight to Moscow, Petrov works on his official report. He knows what he's supposed to write, that American automation is impressive but wasteful capitalist excess, that Soviet industry can adopt useful techniques while avoiding capitalist exploitation, that the Soviet system's focus on full employment represents superior social policy. But he can't write those words honestly. What he witnessed wasn't excess. It was the future of manufacturing, and Soviet industry was decades behind. His final report to the Ministry of Automotive Industry concludes, American automotive superiority is not propaganda or temporary advantage. It represents fundamental capability difference requiring complete restructuring of Soviet industrial approach to close. Under current system constraints, cannot compete with American production efficiency or quality levels. Technology gap estimated at 20 years minimum. The report circulates among Soviet industrial planners. Some dismiss it as defeatist, Western-influenced thinking. Others recognize uncomfortable truths in Petrov's assessment. But even those who acknowledge the gap struggle to identify solutions. Soviet industry can't simply purchase American robots and install them. The robots require supporting infrastructure of reliable electricity, computer systems, trained technicians, and supply chain coordination that Soviet factories lack. More fundamentally, automation requires cultural change, accepting worker input, encouraging innovation, allowing competition between factories, measuring success by efficiency rather than plan quota fulfillment. These changes challenge basic Soviet economic philosophy. 3 members of Petrov's delegation requested political asylum before returning to the USSR. 2 engineers and 1 factory manager submitted requests to American authorities during the stopover in Frankfurt, claiming they could not return to Soviet industrial conditions after seeing what modern manufacturing looked like. Their debriefings reveal consistent themes: frustration with Soviet technological backwardness, recognition that political constraints prevent necessary reforms, and despair that Soviet industry will fall further behind as American automation advances. One engineer, speaking with American immigration officials, describes returning to Vaz after seeing Ford Rouge as going from the future back to the past, knowing that the past is all we will have. Soviet automotive production peaked in 1987 at approximately 1.3 million vehicles. American production that same year exceeded 11 million vehicles. The quality gap was even wider than the production volume gap. American vehicles were becoming increasingly reliable, with defect rates dropping year over year as automation improved consistency. Soviet vehicles maintained persistent quality problems that consumers accepted because no alternatives existed. When the Soviet Union collapsed in 1991 and import restrictions ended, Soviet automotive demand shifted immediately to foreign manufacturers. Consumers who could afford choices chose Japanese, European, or American vehicles over domestic options every time. The Soviet automotive industry effectively ceased to exist as a competitive manufacturer almost overnight. Modern Russia assembles some vehicles domestically, primarily foreign brands produced through licensing agreements or joint ventures, but uses imported components and foreign technology for most critical systems. The glory days of Soviet industrial pride in facilities like Vaz have given way to recognition that decades of isolation from competitive pressure and technological innovation created a capability gap too wide to bridge after the system collapsed. The automation revolution that American manufacturers embraced in the 1970s and 1980s became the global standard by the 1990s, with Japanese manufacturers taking American concepts and refining them into even more efficient production systems. Soviet industry missed that revolution entirely, remaining trapped in mid-20th century manufacturing methods while the rest of the industrial world moved forward. Petrov's report warned Soviet authorities that American automotive superiority represented a 20-year technology gap. He was probably too optimistic. The gap wasn't just technological. It was philosophical, organizational, and cultural. American industry embraced automation because competitive pressure forced efficiency, because workers contributed ideas that improved systems, because free market economics rewarded innovation and punished stagnation. Soviet industry resisted automation because central planning couldn't coordinate the complexity, because political ideology prevented worker input, because monopoly conditions removed any incentive to improve. One system encouraged evolution toward greater capability. The other system locked itself into the methods of an earlier era and called that stability. The Rouge Complex continues operating today, extensively modernized with even more advanced automation than what shocked Petrov in 1987. Ford now employs more than 2,000 robots at Rouge alone, with artificial intelligence systems beginning to supplement traditional programmed automation. American automotive manufacturing has moved beyond just automation to integration with global supply networks, real-time optimization, and quality control systems that catch potential defects before they occur, rather than after. The gap between what American industry can achieve and what Soviet industry achieved before its collapse hasn't narrowed. It's widened into an abyss that demonstrates how free market innovation compounds over time, while planned economies stagnate. Soviet engineers looked at American automotive plants and saw impossible efficiency. American engineers looked at their factories and saw opportunities for further improvement. The difference between those perspectives explains much about why one system thrived while the other collapsed. Continuous improvement requires believing better is possible and having systems that reward achieving it. Soviet industry believed its current methods were sufficient and punished suggesting otherwise. When those philosophies produced factory floors, One generated the automated efficiency of Rouge, while the other generated the manual labor of Vas-y. When consumers could finally choose between products from those different philosophies, they voted with their purchases for the system that had embraced progress rather than resisted it. The Soviet automotive industry built cars with hands, one vehicle at a time, through labor-intensive methods that belonged to an earlier industrial age. America built them with minds, with engineering, automation, computer control, and worker-contributed innovation that created production systems representing the future of manufacturing. When Petrov stood on the Rouge production floor in 1987, watching robots build vehicles faster and better than human workers could, he was witnessing more than just advanced technology. He was seeing the inevitable result of two different economic philosophies applied to industrial production over 40 years. One philosophy created continuous evolution toward greater capability. The other created stagnation defended by ideology. The factories those philosophies built told the story of which approach would prevail long before the Soviet system officially acknowledged defeat. Soviets built cars with hands, America built them with minds.